All right, so the autonomic and somatic nervous system. So I thought I'd put together a little video that would maybe help us, since the guy kind of had an accent today, he wasn't all that clear. We were kind of covering this in a couple classes too, so I feel like now at this point, we're probably going to get tested. They're just going to test the fuck out of it because it's such testable stuff. So I like learned this in a lot of my classes in undergrad, so I think I've got a pretty good handle on it, so I thought I'd make a video and see if you guys like it. So there's two divisions of the nervous system, so what we got is we got the somatic, which is under voluntary control, and the autonomic, which is not under voluntary control. Okay, so in the somatic nervous system, it's pretty simple. There's a one neuron chain, cell bodies in the spinal cord. That neuron takes its axon, goes out of the spinal cord, and through our different roots, or through our ventral root, excuse me, and releases acetylcholine to a motor end plate at a neuromuscular junction. And the neurotransmitter it releases is acetylcholine. And we all know the kind of different drugs that work on that now, from botulinum and stuff like that. And then we've got one receptor that the muscle cell expresses to pick up on that action potential in that neurotransmitter. So that one receptor is the N1 nicotinic receptor. So they didn't do a really good job of explaining this, but the nicotinic receptors are named such because they are stimulated by nicotine. So just like from plants, tobacco, these stimulate these. It can get stimulated by acetylcholine or it can get stimulated by nicotine, but it's going to activate it at some degree. Okay? So then where it gets more complicated, as if that's pretty easy, is the autonomic nervous system. So the autonomic nervous system has two tracks in it. And the way I like to think about it is the sympathetic is the fight or flight, and the parasympathetic is our rest and digest. So like big picture to small picture is what I like to work. And we all know that sympathetic, if we follow a general rule, if we go through all these steps that I'm going to go through here, kind of just the general steps to start out with, we know that whatever effect is going to have on it is going to be preparing our body to fight something or get the hell out of there. And then the parasympathetic, it's our rest and digest, so anytime that is activated, it's going to kind of slow things down. So I think of also this as fast and slow, okay? So the sympathetic tract originates from the thoracic and lumbar regions of the spine. So I think it's like T1 to L3. And then our parasympathetic originates from the cranial and sacral regions of the spine. So a lot of the cranial nerves, and then all the way down the cervical vertebrae, and then out of our sacrum. So she said there's two rules for this, Buteric did. She said the first rule is that they all have two neuron chains. So I thought that I'd like to kind of start out the differences and comparing and contrasting the two tracks of the autonomic nervous system by kind of comparing it first. So they both have two neurons, so a two neuron chain. Okay, so one of those neurons is going to start in the cell body on both of them. The cell body is going to be in the spinal cord. Okay, the first neuron in both of them is going to release acetylcholine. So that's kind of an important point that I think they kind of glossed over. And this guy who seems super just brilliant, but not that great a teacher because he kind of expects us to know it, he kind of glossed over that today too. So then we've got our other similarities of our receptors. So our receptors are going to be the nicotinic neuron receptors. So when a neuron, the first neuron, comes out of the spinal cord, it's going to, well, there's two different routes it's got to take, whether it's sympathetic or parasympathetic, as I'll show here in a second. But it's going to release acetylcholine and bind on both of the parasympathetic parasympathetic and sympathetic. On the second nerve in the chain, just like this, that's my first neuron. Here's my second one. On both of these tracks, on the sympathetic and parasympathetic, it's going to release the acetylcholine and it's going to bind to nicotinic 2 receptors. So nicotinic 2 is different than the somatic 1, so that's specific. They have a little bit different receptor kind that allows them to be activated specifically. So not all the acetylcholine run around in the body can activate the autonomic nervous system. Okay. So they're specific for it, and that's how the drugs will act on that. So the sympathetic is more complex. Its anatomy is more complex than the parasympathetic. Okay. So we all know that when we're sending out nerve impulses or communication to the viscera, which is, of course, autonomic, that it's going to come out the ventral root. So I drew this before, but then I figured out my camera. I was like making a whole video, and then I realized my camera wasn't picking up the writing on the board here, so I had to make a new one. So I didn't erase it because, you know, I hate erasing things and moving on. So we've got the dorsal root, and which can be identified by the ganglion there, which is in it. And then we've got the ventral roots. The ventral root is where information is sent. So autonomic is always sending information. Okay? So it's always a motor neuron. I should put that up there. That was the first rule, I believe. The second rule was that it was 2 neuron chains. So the sympathetic tract of the autonomic nervous system is going to originate in the thoracic columbar. Its first neuron is going to have its cell body in the lateral horns, that's here, of the spinal cord. Its axon is going to travel out through the ventral horn. Then it's going to meet up in the spinal nerve. I'm going to trace along here. It's going to meet up in the spinal nerve where it heads to the gray or the white ramus communicus. So the white ramus communicus, it goes to the vertebral ganglion. So at this point it can kind of do 2 things. It can either synapse there, or it can travel through the splanchnic nerve to the perivertebral or prevertebral ganglion. So it can do 2 things, and what makes that decision is based on where the sensation or where the information needs to go. So if it's going to stay here in the paravertebral ganglion, it's going to go to the abdominal wall or the limbs, okay? If it does that, it's going to synapse right in the paravertebral ganglion. So it'll synapse right there. Now we know that since this is a 2 neuron chain, the first neuron or neurotransmitter that it's going to release in that synapse is going to be acetylcholine, and it's going to bind to nicotinic N2 receptors, which are different than the somatic receptors of N1, and it's going to activate the second neuron in the chain, which comes back out of the paravertebral ganglion through the gray ramus communicus and out to its respective dorsal or ventral rami, primary rami. If it is going to be destined for the abdominal viscera or the pelvic viscera, it is not going to synapse here. It's going to keep going. The axon keeps going through the splanchnic nerve. Splanchnic nerve travels to the perivertebral or prevertebral or perivertebral ganglion where it can synapse. It does the same thing though. It also releases the neurotransmitter, acetylcholine, which binds to nicotinic receptors, or N2 ones, on the second neuron. Okay, so it binds to these N2 receptors. From there, it can activate that second neuron, which cell body is in this ganglion. It's also in here, which can then send a signal down its axon, where it meets up with the effector organ. Okay. The parasympathetic is much easier. It's like the easiest one to remember because the parasympathetic doesn't have, even though it's a 2 neuron chain, it doesn't do all these different things with ganglions at different parts of the spinal cord, just out the spinal cord. So the easiest way to remember this is because, or why this happens, is because it has a long first neuron in the chain. And the sympathetic tract has a short first neuron in the chain. I don't believe they did a good job of explaining that, but when I taught human bio, I always emphasize that because it's the easiest way to know how these things work. Is that the sympathetic has the short neuron, so it's just going to one of these ganglion here, which are right next to the spinal cord, and then our parasympathetic has a really long first neuron. So it's going to come out of the ventral root with the cell body in these ventral horns. It's going to go right out here or here, and the axon is going to go all the way until it meets its effector organ or near the effector organ. Then it's going to meet a cell body of the second neuron, which is going to have a very short chain, and then the organ is right there. In this case, the heart. That's right there. So this first neuron, just like our ones over here, it's the same, releases acetylcholine to the second neuron in the chain, which picks up the signal using nicotinic N2 receptors. Okay? So again, the biggest thing to remember is that it's a long first neuron and a short second neuron. Okay? And these ones have, or in the sympathetic tract, you have short first neurons and long second neurons because the distance is traveled. Okay? Alright, so after the signal is picked up and it's sent down, there has to be a synapse with a effector organ. So this is where we're going to get into tomorrow and next week, and they differ so much on what they release from their terminus and what the receptors are that pick up the neurotransmitter that a lot of drugs act upon. So I have a feeling that's why they want us to learn this so well. So the second neuron in the sympathetic tract either releases norepi or epi. So that would explain, or the easiest way to remember this, is since it's the sympathetic tract, those are your 2 fight or flight hormones. So epi, we know that you give it in EpiPens and stuff like that. You also give it in allergic reactions. And so same with norepi, which is a vasopressor. Those both activate fight or flight. And when I always think about it, I always think we give epi to cardiac patients or patients that are coding, and when I was in the ER. So whenever we were giving them epi, you'd always see a jump in their heart rate like crazy if it wasn't already going crazy. And also a spike in their blood pressure too. If we gave them norepi as well, that would really happen. So it just accelerates things. So these are your stress hormones. Another good way to remember that norepi and epi are released by the sympathetic tract and from the second neuron terminus is the movie Pulp Fiction when the guy stabs him in the chest with adrenaline, and adrenaline is epi, and that gets him back to life. So that's a good way to remember that. So the receptors that these two ones bind to, though, vary by organ. So each organ has a specific receptor, just like the nicotinic receptors were differing for the autonomic and somatic nervous system in the first part. The effector organ's receptors differ for what organ it's synapsing. Same thing with the parasympathetic. It's going to release acetylcholine this time, and it's going to bind to muscarinic receptors. Okay, so muscarinic receptors are stimulated by muscarinic mushrooms. So they actually grow in Iowa. I don't know if you've probably actually seen, some people probably actually seen them and don't even know. But if you eat them, they poison you via the parasympathetic tract of the nervous system. And I don't know, I gotta look that up again. I don't know how that works out. But yeah, so let me think, am I forgetting anything here? I don't believe so. So yeah, that's just the general overview and the way things kind of go in the autonomic, somatic, and sympathetic and parasympathetic divisions of the autonomic nervous system. So hopefully this helps people.